this lesson has essential trigonometric identities here. So again, using the unit circle, we know here that this point is really just cosine theta comma sine theta. Using the same principle of a unit circle, right, where this angle is theta, as we have formed a triangle here, with the cosine, again, theta really just being the horizontal component and sine theta being the vertical component. So you can see that here. Now with trig identities, we know we know that the unit circle, because it's a unit circle, this must be one unit, which is just the radius of the circle. Well, let's think about something. If we were to use a Pythagorean theorem, which we definitely can because it's a right-angled triangle, we know that the horizontal component of the triangle is cosine theta, and we know that the vertical component is sine theta, right? That's how we got this point here. And we can use a Pythagorean theorem really to prove or to show that there's an identity here that exists, which is really saying the square of this leg is cosine theta squared. That's how we write it. We place the square here on top of cos here, and then theta plus sine square theta. That is equal to the hypotenuse squared using the Pythagorean theorem, which is really just 1 times 1, 1. So we have proved here the first identity, and obviously in the later lessons I'll be going over problems where you may need to use these identities to really prove either one side equals another side, or really in equations as well. So, and then now there are two other ones, and the good thing about them is that you don't have to memorize those identities, the other two identities. You can really just derive these two identities from this one itself. And how you do that is, so you are given cosine square theta plus sine square theta is equal to 1. So you can divide both sides by cosine square theta. So you can divide this by cosine square theta. And then if you do that to this side, you must divide this by cosine square theta. And really, obviously, because this is over the entire denominator, you can really split this into two fractions. You can write this as cosine square theta over cosine square theta plus sine square theta over cosine square theta is equal to this, 1 over cosine square theta. And so really what this, what cosine square theta over cosine square theta is just 1, so we can write this as 1. Sine square theta divided by cosine square theta is tangent square theta. Again, if you got confused there, it's just really, you can write this as sine theta over cosine theta times by sine theta over cosine theta. Sine theta over cosine theta is just tangent theta, and so you're just multiplying that by tangent theta, which is tangent square theta. And that should give you 1 over cosine square theta. And so that, again, 1 over cosine theta is secant theta, and if you times that by another 1 over cosine theta, that's you're multiplying it by another secant theta. So that's just secant, or SEC, again that's the notation, secant square theta. So here's another identity here. So you want to write those two down, you can. And now I'll tell you the third one. So here, as you saw, I divided the entire expression by cosine square theta. So now, instead of dividing it by cosine square theta, let's see what happens if you divide it by sine square theta. So you can divide this by sine square theta. So again, you can split this, right? So you have cosine square theta divided by sine square theta plus sine square theta divided by sine square theta, and that's giving you 1 divided by sine square theta. So really, now we look at this. Cosine square theta divided by sine square theta. If you recall from one of the previous lessons, sine theta over cosine theta is obviously tangent theta, and we said that there's another ratio that exists, which is the reciprocal of tangent theta, that is cotangent, right, which is cosine theta divided by sine theta. Now if you have that times by that, it's really just cotangent square theta. Sine square theta divided by sine square theta is 1 plus 1. And really looking at 1 over sine square theta. Now we know that 1 over sine theta is cosecant theta, right? Again, multiplying that by itself is really just cosecant square theta. So this is the other identity. Cotangent square theta plus 1 is equal to cosecant square theta. So here we have just derived the three important trigonometric identities here. So thanks for watching.